Two concentric circular coils, one of small radius R1 and other is having large radius R2, such that R1 is very less as compared to R2, are placed coaxially with the centers coinciding. Obtain the mutual inductance of the arrangement. Okay, two concentric circles are given, right? Okay. What is the expression for magnetic field at the center of the coil? Current carrying coil? Yes, magnetic field equal to mu 0 I by 2R. Now, concentric coil, one is R1, another is R2. Magnetic field at the center of second coil, mu 0 I by 2R2. Now, since R1 is very small as compared to R2, this field is uniform over the small coil. Why field is uniform? Because it is given that R1 is very small with respect to R2. Okay. Flux through inner, that is smaller coil, flux is equal to A into pi R1 square. Flux is equal to V dot A. B is mu 0 I by 2 R2, area of the smaller coil pi R1 square. So we got the flux. Mutual induction, inductance M equal to phi by I. Now we have to substitute. Phi value equal to mu 0 I pi R1 square divided by 2R2 divided by I, current will get cancelled. Mu 0 pi R1 square divided by R2. What are the key points here? Current flowing in large coil, it produces a magnetic field. Small coil radius R1 lies near the center. Since R1 is very small as compared to R2, field over the small coil is almost uniform. Current I flows through the outer coil of radius 2.